Okay, discussing the solution for number one from the problems to submit, chapter 3, day 1, scatterplots and correlation. Apologies for the typo up here. Things happen. Okay, so here we have a figure shows a scatter plot of IQ and grade point average. Generally speaking, the first thing you state on a scatter plot is your explanatory. The second thing you state is your response. Notice on this axis, I don't have to start at 0 for a scatter plot. It's okay to have it scaled, but the distances should be the same. Right over here, the grade point average goes down to 0, so we see it. Right, so we have 60 for the x-axis, 0 for the y-axis. That's okay. Okay. So we're asked, does the plot show a positive or negative association between the variables, and is it reasonable? Right, if we look at this and we think of being able to put in a best fit line, right, our y hat, there does seem to be a moderate positive linear relationship between IQ and GPA for our population. This population being 78 8th grade students at some rural Midwestern school. And generally we would expect higher IQ to do better in school, therefore have a higher GPA, right? That a higher IQ, right, is associated with a higher GPA. Right? That's not unreasonable. Okay, then what's the form of the relationship? Is it very strong? Explain your answers. Right? Well, the form is linear or nonlinear, and the strength is what we have. Right? So we should also always talk about the strength, the direction, and the form. Right? So here, the form, it's linear. Right? A straight line seems to fit the data well, particularly up here at higher GPA and IQ. Okay, we would say that the strength is probably moderate because the residuals at lower GPAs and IQ, right, that down here, the distance from the actual values to our line of best fit, and this is an approximate line of best fit, it's not the exact one, but we can imagine what it might look like, that those residuals at the lower ones are fairly large in comparison to the residuals at the higher GPAs and IQs, right? That up here, things are more clustered together in a nice line than down here, so we might say that we have a moderate strength, okay? And once again, depending on the area of study that you're doing, you might consider this to be a strong relationship, or you might consider this to be weak, but generally would say in this situation we're moderate. Now, at the bottom of the plot, we have several points that we might call outliers, right? So these points down here, one student in particular has a very low GPA despite an average IQ score, and an average IQ, depending on the population, is around 100 to 110 or 115, depending on the population, right? And what are the approximate IQ and GPA for this student? Well, this is our student that's very low, right, despite an average IQ score, right? This is the lowest. And if we look at the GPA, right, it's something around 105, right, 104, 103, but we can see it's between 104 and 105 and seems to be closer to 105. So the IQ about 105. The GPA, well, that GPA is way down here, right? I mean, if I were to come over here, set up a ruler and kind of look across, that GPA seems to be below 1, right? It's not at 0, clearly, but it seems to be below 1, right? Now, you might say 0.5, 0.6, 0.4, right? But it's a low GPA. Okay? And then, what are the approximate GPA and IQ score for the student with the highest IQ? Would you consider this student an outlier? Why or why not? Well, the highest IQ is this student, right? Boom, over here, there's the IQ. What is it? Well, it seems to be somewhere around 135. And what seems to be their GPA? Well, if I come over here, go across, the GPA seems to be somewhere around 8. Okay? And notice that we are clear in identifying what we're talking about. Right? Would you consider this student an outlier? Why or why not? Well, the residual for that student, right, if we look at this, how far away is this from our line? The residual for our student here seems to be pretty in line with what the others would be, right? I'm not sure exactly where this best fit line would be, but these points are all clustered pretty close. right? So we would not consider it an outlier. Very likely it's not an outlier, right? It is close to the other data in the x and the y direction. Okay? In order to be an outlier, you need to be pretty far in the x direction, in which case you would be a high leverage point, or you need to be pretty far in the y direction. Okay? And really, in the y direction and in the x direction being pretty far, then that's going to have a much greater effect. And that's why we say that the correlation and the linear regression line, the least squares regression line, that's why we say that those are not resistant measures. These outliers will affect them greatly. Right? But this point over here, not really much of an outlier. This point down here, yeah, right, we might have that our, because of this data, we might have that our line of best fit, maybe it's over there because these points down here are pulling it down, right? Or maybe our line of best fit, right? Maybe the line of best fit is going up that direction, right? We're really not quite sure until we do all our analysis. But most likely it's going to be close to the red line, but you can consider the different things that could occur. Okay, so you have these approximations. Make sure that you are understanding the concepts associated with this. If you have questions, please make sure that you ask them for clarification.